Okay. In standard xy coordinate plane, at what point does a line for the equation 3x... Don't we just set y equal to 0 and then solve the equation?
Not quite. You're close. It's not y that's equal to 0. When you cross the y-axis, what is it?
Oh,
0.
x is equal to 0.
Right. So what's the
Okay. I mean, 7y minus 2 equals 0, 7 equals 2, y equals 2, 7. C.
Yeah. Always remember that when you're talking intercepts, the x-intercept comes when y is 0, and the y-intercept comes when x is 0.
Mm-hmm. Okay. Which of the following statements identify the same set as the graph below? Huh. Which of the following? X must be greater than 4. And isn't it F?
Yeah, it is.
Because the open circle means it's touching, but it's not equal to.
Exactly.
And the closed circle means equal to.
Take a look at H.
H. Huh.
It's a typo. You will
Is it typo?
Yeah, it has to be, because you will, well, it's the same as F, is it not? Am I misreading something?
Yeah, it's just or instead of and.
Ah, it's not a typo. Excuse me. It's definitely F.
What's the difference between H and F, though?
If it was H, it would actually be this. In other words, if it said x was greater than minus 4, greater than or equal to, it would be that entire area, right?
Uh-huh.
Or x is less than 6, which would be that entire area.
Okay.
That's the difference between and or.
Okay.
You see it? In other words, if it's and, both of them have to be true. And F defines this interval right here.
Mm-hmm.
But if it's or, then either one can be true. And H says that x is less than minus 4, or excuse me, x is greater than minus 4, or x is less than 6. Well, that includes the entire number line.
Okay.
Or it's infinity, or let's say negative 1,000 satisfies x, because it can be or x is less than 6. So negative 1,000 would satisfy that.
Okay.
And plus 1,000,000 would satisfy that. So there is a huge difference between H and F. Unfortunately,
Okay.
they don't spend a lot of time in the classroom teaching you the difference between and or.
Okay.
But that's basically it. In other words, when you see an and, both of them have to be true.
Okay.
When you see an or, just means either one can be true.
Mm-hmm. Okay. That's good clarification.
Well, I'm almost a little disappointed that they have that problem on the test, because I don't have very many students that ever ever bring me problems where some of them are and some of them are or, and they have to figure out the difference. So why they have that question on the ACT, I'm not sure. But that's the difference between and or.
Okay. So for this one, it's asking the perimeter of the figure shown below. So 6 times 6.
Usually students like yourself have the most problem with geometry questions on the ACT. And the reason is that you're much further removed from your geometry class. What's it been, 2 years or 3 years since you had geometry?
Two for me.
Right. Whereas some students that aren't fast track or aren't going to the school you go to maybe had geometry last year. So
yeah.
It's what I find is that most of the students I work with have the most difficulty with geometry problems. And it's precisely because of the fact that it's been a while since they've had geometry. And I actually have some practice tests that are all geometry problems. One of my students' parents went through and cut out and pasted all geometry problems.
Oh, wow.
Yeah, it's a terrific thing, actually. Once we've been through 1 or 2 tests, I figured we'd probably get to that.
Okay.
Although you're taking the test this Saturday, is that right?
Yeah, this Saturday. So I'm just kind of going over like refreshers right now, and then I've been taking practice tests and such.
You'll have another chance to take it, right?
Yeah, for sure. This is my first time at it.
Okay. Well,
and then I'll be taking the 8th.
At some point before you take it for the final time, I've got some really good practice tests that go over nothing but geometry problems. And that would probably be worthwhile for you.
Yeah.
So this problem.
So first off, with the process of elimination, you can cross out A immediately because 6 by 6 with a removed figure. 6 by 6 is 36. That's the area of the square of a hole, but it doesn't have a hole. It's missing that. Area of a square. I know the base is the 1/2 base times height, and I'm looking for height.
Well, what's the perimeter?
6 by 6 by 6 by...
That's not the hard part. That's the easy part.
Yeah.
The hard part is figuring out what that is and what that is. Now, they are both the same. In other words, I can label them X and X.
Okay.
But in order to figure out what they are, let's draw a horizontal line there.
Okay.
You know what? I've done this problem many times before, and every time I do it, I realize that you're better off drawing the horizontal line there.
Okay.
Reason being is, what's this angle right here that I'm pointing at?
That is 60.
And this angle over here, also 60?
Yeah.
Which makes that 60.
Oh, so it's an equilateral triangle.
Exactly. So
that means the side, okay.
What is X?
X is 6.
Exactly.
So, all right,
now we got 6 plus 6 plus 6 plus 6 plus 6. 5 6s is 30.
Oh, it asked for the perimeter. Oh man, I read that wrong.
Yeah, well, that's a good lesson though. When I'm doing these problems from ACT practice tests, I find that the most common mistake I make when I'm doing them is I don't read the problem correctly.
Yeah,
So,
I think I would have known how to attack that if I read
well,
the.
so you read the problem as being what is x?
I read the problem. It's like, what is the area of the figure shown below?
The area.
I don't know. I confuse the parameter of the
Well,
area.
that would be harder.
Yeah,
So
that's why I crossed out 36 immediately because I thought.
okay, I got you.
Yeah.
I got you. Well, that just shows you that the danger is that if you misread the problem and they have one of the answer to the area on there,
Yeah.
and if they don't have the answer to the area, then you can probably get away with that misread. But always try to read the problem correctly.
Yep. Okay.
36.
If x and y are real, then what must be true of the values of x and y? Well, you can't square root a negative, right?
It's correct.
So both x and y must be positive? G?
Well, what if x and y were negative?
If you had a negative,
Cubed,
yeah,
still negative,
it's still negative.
divided by a negative, that becomes positive.
Okay.
So it appears that they could each be negative or positive. So right away you're faced with a contradiction because F says negative, G says positive. So let's read on.
So both x and y can be both negative or positive?
Exactly.
Okay. I see how that goes.
In other words, you can't really say F is true. They don't have to both be negative. You can't say G is true. They don't have to both be positive. What they have to both be is either positive or both negative.
Okay, yeah.
And notice that you don't really have to solve this. If I tried to solve this, I would square both sides, right?
Yeah.
Well, what do I get when I square both sides? I get this equals 16. Doesn't really help with the solving the problem.
No.
And yet, if you were to look at this problem without looking at the answers, you might spend a considerable amount of time doing that and then trying to solve that equation, all of which would be wasted effort. Whereas if you look at the answers before you try to solve the problem, then you realize that, well, this is not just, you're not really trying to solve the problem, and you can save yourself a lot of time.
Yeah. Okay.
You hit on the right answer immediately. In other words, the immediate thing to see is that this inside the radical sign has to be positive. That's the only thing that matters for this problem. Is right.
But inside the parentheses, it can be okay.
Well, inside the radical sign has to be positive. In other words, say 3 times x cubed over 2y has to be greater than or equal to 0. That's what you solve. And once you determine that, then you realize, well, that's F is true almost, G is true almost, H is true 100% of the time. This is a little bit of a strange problem in the sense that in a way they kind of give you 3 correct answers.
Yeah.
The key word,
but you got to figure out which one's the most correct.
Now the key word is both. In other words, F says they both have to be negative, but that's not really a true statement. They both have to either be negative or positive. So the only true statement on those 5 answers is H.
Okay, yeah.
Whatever you do, you're taking this test Saturday,
Yeah.
sure you get a good night's sleep.
Mm-hmm.
It's a long test. This is like a 3.5-hour test, I think.
Yeah, it is.
And the biggest problem you're going to face is getting tired and losing mental focus.
Uh-huh.
So whatever you can do to help that, you want to do.
Yeah.
And number one thing is getting a good night's sleep, having a good breakfast when you wake up in the morning, and then go in there with confidence.
Mm-hmm.
About the only 3 things I can suggest. Maybe do you drink coffee or tea?
No.
Maybe have a cup of tea. It's got a little caffeine in it.
Yeah. Okay.
Okay? Caffeine not only keeps you alert and awake, but it helps you to focus a little bit.
Mm-hmm. Okay. Okay. For all pairs of real numbers, A and S. For all pairs of real numbers. Huh.
Don't get confused by the first part of these things. In other words, you could eliminate the entire first part. And if it said A equals 2S plus 9, what does S equal to? That's the only thing that matters.
Okay.
That second part.
9. S is equal to...
Solve it algebraically,
I would...
step by step.
First, I would subtract the 9. So A minus 9 equals 2S, and then I divide it by 2.
So this is our answer.
And,
We don't see that answer on there. Oh, yes, we do, actually.
yeah, it's D.
Yeah, it's D. But what they could have put on there is this. And for some reason, I remember that's what they had on there, was not the thing you would get immediately when you solved it, but do you see why these are equal?
Yeah, because they're still both being divided by 2.
As long as you have a single entity in the denominator, you can split it up into 2 fractions.
Uh-huh.
That fraction and that fraction. If you have a double entity like this, you cannot do that. A over B plus C is not A over B plus A over C. Be careful with that. You have to have a single denominator, not a binomial denominator.
Okay. Okay. What is the slope of any line perpendicular to the y-axis in the xy coordinate plane? The slope of any line perpendicular to the y-axis, so
There's a line perpendicular to the y-axis.
yeah. Well, I mean, slope of any line. I feel like this. Oh, slope would be 0, right? Because if it's perpendicular, it doesn't rise or drop.
Let's talk about slopes a little bit. What's the slope of this line? Approximately.
Just 1, x?
Yeah, 1 equals.
Yeah.
Slope equals 1. I go up 1 and over 1. Up 1 and over 1.
Mm-hmm.
Okay. What's the slope of this line? Approximately.
1/2.
And what's the slope of this line? Approximately.
2.
So that tells you that the flatter the line gets, the closer it gets to 0. which means the slope of a horizontal line has to be 0.
Okay.
What's the slope of a vertical line? Undefined.
Undefined.
Actually infinity, but we'll leave that for another discussion.
Okay.
But notice that the steeper the slope, the bigger the slope number is. And the flatter the slope, the smaller the number is. So that'll always answer the question for you as to what's the slope of a horizontal line. It's got to be 0. In other words, I go from 1 to 1/2 to, that would be like 1/4. Flatter it gets, the closer it gets to 0. So a horizontal line is a 0 slope. And the steeper it gets, the bigger it gets. In other words, the slope of this line right here might be 100.
Okay.
And the slope of a truly perpendicular line, I would actually say, is infinity. I understand that they don't like to use the word infinity, and they would prefer to use the word undefined, but you can see that it's infinitely large. In other words, the steeper the slope gets, the larger m gets. And when you reach a totally vertical slope, it's infinite slope.
Yeah, okay.
Call it undefined for other reasons, but just know that undefined and infinity frequently mean the same.
Okay. Okay.
39. So it's starting to get tougher because we're in the 30s, 40s, and 50s. These are going to be your toughest problems.
Okay.
Some students, I start every test out on 30. Just and I might do that with, well, when we get serious about doing the ACT, I might do that with you.
Yeah, okay.
You don't need much help on 1 through 30 problems. They're going to be easy or medium easy. It's 30 through 60 that are the tougher problems.
Okay. In an xy coordinate plane, the line with the equation of 5y across the x-axis at point coordinates a, b. What is the value of a? It crosses the x-axis. Okay.
Let me ask you, what's the value of b, first of all?
The value of b would be 0?
Yeah. In other words, the fact that it's crossing the x-axis means the y-coordinate has to be 0 by definition. So they're basically saying, what's the x-coordinate?
That's kind of easy.
Yeah, not hard.
Here equals 25, x minus 50, 25, x equals 2?
Yep.
Okay. It's kind of not the problem's hard, just the wording's hard to...
You're right, absolutely. No, I agree 100% with you. They do almost everything possible to confuse you. And they succeed. Yeah, you have to be able to take their problems and figure out exactly what it really is that they're asking for. And man, they could put information in there that is not necessary. They can put words in there that aren't really necessary. You kind of have to be able to decipher what the gist of the problem really is. All right, here's another trig problem.
This one is tan A times cosine B.
Okay.
So
what's tan
A is 4 over 3.
Okay. It's cosine.
Cosine B equals 4 over 5.
It's the product of those two.
15 16. 16 15.
Right. Again,
Okay.
trig problem that's really easy.
Yeah.
There's 4 trig problems on there, and for anybody that's had trig, these should be gifts.
Uh,
I once had a student that told me she had a tutor once and said, let's just forget the trig and just accept the fact that you're going to miss all 4 of them. Well,
oh,
in your case, you're going to get all 4 of them right.
yeah.
It's a gift for you because they don't put any tough trig problems on there. In fact, there's 4 trig problems and 2 conic section problems. And you should get all 6 of those right. Because the 2 conic sections are only circles and ellipses, so there's really no reason to miss any of those 6 questions. Those are actually considered the 6 of the more difficult questions on these tests. So
Okay.
you're in good shape if you're going to get all 6 of difficult questions.
Yeah. Okay. Amy can run 3 miles in S minutes at pace. How many miles can she run in 50 minutes? Oh, and it wants the equation. Okay.
Good. You looked at the answers.
At what pace? 3 miles in S minutes. 3 times S divided by 50 is what my first guess would be, so that'd be A. Or
It's been a while since I've done this. And so I don't know right offhand if that's A. You might be right. But let's talk about a different way of solving it.
okay.
When you have variables in the question and variables in the answers, that means S could be anything. And you can pick anything you want.
Yeah.
So this is a great example of where you want to pick numbers. In other words, pick an S. What's a great S to pick?
5
How about 50?
or 1? Sorry?
How about 50?
50? Okay.
Notice that if you pick 50 for S, you can let S equal anything, but the easiest thing to let it equal is 50 because that answers the question. At that pace, how many miles can she run in 50 minutes? Well, obviously 3. So picking S of 50, one of the answers has to equal 3. A equals 3.
Okay.
And there you go. You got the answer. Notice that B
I see.
B does not equal 3. C does not equal 3. D does not equal 3. Now, E does equal 3. So this is one of the problems with picking numbers, is that sometimes when you make up a number for the variable, you can actually get 2 answers that both equal that. Well, what do you do when that happens? Go back and pick another number. Well,
Okay.
I liked what you picked,
5?
5 for S. So let's let S equal 5. How far is she going to run in 5 minutes?
3 miles.
Huh? If she can run 3 miles, oh, hold on just a second. Excuse me, let me back up a little bit. No, that's fine. That's fine. We'll make her superhuman.
Yeah.
We'll let S equal 5. So if she can run 3 miles in 5 minutes, how many miles is she going to run in 50 minutes?
3 miles in 5 minutes. She'll run 30 miles.
Yeah. So we have to find, we know the answer is either A or E, right?
Uh,
Which one is equal to 30 when we let s equal 5?
uh, 3 times 5 equals 15 divided by 50. So it's E because A is not correct.
Exactly. So
Okay.
the first instincts were actually wrong. And making up numbers for s led us to the right answer, which is E. And
Okay.
most of the time when you make up a number, you're going to only find one of the answers equals to that number. Okay? So usually it's a one-step process. But where you want to look for, in other words, there's three ways to solve an ACT problem. One is algebraic, the other is back solving, and the third is pick numbers and back solve. That's what
Okay.
every single problem can be solved by one of those three techniques. And when you want to use the third technique is when you have variables in the problem and the answers, which
Okay.
means S could be anything. In other words, clearly if they haven't defined S, then you could make it be anything. And so you can pick really convenient numbers. Now the first number I conveniently picked was 50 because that immediately gives you the answer. If she can run 3 miles in 50 minutes, how many miles can she run in 50 minutes? 3.
Mm,
Okay. But that gave us 2 answers. So got to go back and pick a different S.
okay. Okay. Cool.
But
Uh,
that's a great problem for when you want to use picking numbers.
okay.
And a lot of the times there'll be 2 or 3 variables in the problem, and every answer has those same 2 or 3 variables. So whenever
Oh,
you see a
okay.
problem that has it like that, know that you can make up values for these 2 or 3 variables, or 1, 2, and 3 variables. And usually when you make up numbers, it's much easier to come up with the solution
Yeah.
than
Okay.
it is to come up with the equation.
Okay.
42.
An oil tank contains each gallon of oil weighs about how many pounds is the oil in the tank weigh? Contains 180 gallons. Each gallon of oil weighs about 6 pounds. So let's just do 6 times 4,800.
What do you get?
Sorry, let me just
Hold
get
on.
my calculator.
Don't bring your calculator out. Multiply 6 times
Okay.
4. What do you get?
6 times 4 equals 24.
What's the answer?
6, oh, it's 28,800.
Gotta be.
Yeah, it's the only one that's in range.
And this is very, very common for the ACT, is that they do not really make it advantageous to have a calculator. You don't need a calculator on almost any of these problems.
Okay.
Because they put the answers such a wide range, there's no way
Uh,
that 6 times 4 can be 46, even with the
yeah.
change of 800. And it's not 6.
I see how that works.
Yeah, so you don't really need a calculator to answer this problem.
Oh,
That it's
okay.
not even, I'm not even sure it's helpful, because it takes you a certain amount of time to multiply 6 times 48. More
Yeah.
time than it takes to look at the answers and realize that it's got to be J.
Uh, okay.
Draw
In
a
the same.
picture. I'm going to draw a picture on this. Angle A is 30 degrees. We'll let that be A. Angle B is 60. So that's 30, that's 60, that makes that 90.
Oh, it's special right triangle.
Yeah. And if AB is 16, what's the area of the triangle? Well, in order to get the area of the triangle, you got to come up with AC and BC.
AC equals 32.
Hypotenuse is always the longest side of a triangle.
Oh, so AC equals 8.
Actually, BC equals 8.
Oh, BC equals 8.
Well, let's figure out how I got that. This is very important for trig. What the unit triangle looks like. The unit 3060. Remember I told you to try to memorize this?
Yeah.
Because if you memorize that, then you can figure out what's the similarity ratio between these two triangles.
1 to 8.
Or I prefer big to little, 8 to 1.
Okay. 8 to 1.
I know that a lot of the school systems go little to big, but to me that's a big mistake. Big to little works so much better. So
Okay.
it's 8 times. So what is BC?
BC is 8.
What is AC?
AC is 8 times root 3.
Okay. So the key on these similarity problems is to always figure out your similarity ratio. Once you do that, then everything else falls into place. So there's our triangle. What's the area of a triangle equal to?
Area of a triangle is equal to 1/2 base times height.
So what does that come out to be?
4 root 3 times 8. So that becomes, is that 4 root 3 times 8? So that becomes 32 root 3?
You got it.
Okay.
C.
Okay. Cool. Okay, consider next component. Goes to the point 3, 0 and is perpendicular to.
What's the most important thing about lines? There's one word. There's one word. Slope.
Slope.
And believe it or not, slope is the most important thing about Algebra 2, about precalculus, and about calculus. All comes down to slope. And the reason is that calculus is all about rate of change. And what is rate of change? Slope.
Okay.
So when you look at any linear equation, very first thing you should become aware of is slope. Not the y-intercept, but slope.
Okay.
What's the slope of this line that they gave us here? Y equal 2x plus 1.
2x, 2.
2. What's the
M
slope
equals
of
2.
the perpendicular?
M equals 2.
No, that's the slope of the line that they gave us. They want to know about the perpendicular line. Well, what's the perpendicular?
Oh, something that okay.
What's the perpendicular? If the slope is 2, what's the slope of the line that's perpendicular to that line?
Negative 1/2.
Okay, so that gives us a lot.
Okay.
In fact, there's only one answer on there that has negative 1/2 as the slope.
Yeah.
So we don't even have to take into consideration the fact that it goes through that point.
Mm-hmm.
Now, we could solve it. In other words, if we had to, if it wasn't multiple choice, then we would know this much. Okay?
Yeah.
In other words, we would know the slope is minus 1/2. And now the fact that it goes through 0, 3 means I can set y equal to 3, set x equal to 0, which makes b equal to 3. So now we know the equation of the line has to be minus 1/2 x plus 3 without multiple choice. We can figure that out. But again, as they are wont to do, they always give you a little shortcut. Notice. In other words, very, very few problems do you actually have to solve as if they were no multiple choices. By giving you multiple choices, they're actually giving the person that figures out how to do it quickly a huge advantage. Because you don't have to solve for this equation. As all you have to know is that the slope is the negative reciprocal. And since they went, did you a big favor by putting that as the only answer that has negative 1/2 as the slope, you're done. You're done with the problem. The moment you figure out that the slope has to be negative 1/2. You don't have to do the rest of the problem. And the rest of the problem could take like a minute, if you didn't realize that. So this is a great question that should be answerable in 10 seconds. But some students might take a minute and a half to answer it.
Okay.
So I guess the message I'm trying to get across is always look at the answers, because they might shorten the length of the time that you have to work on that problem just by only giving you one answer that can be right.
Okay.
All right. 45, the moment I read the first 3 words, a certain rectangle, I'm drawing a rectangle on my piece of paper.
Okay.
Now, it's 2 times long as it is wide. What else should I put on that based on that alone? Forget everything after the first sentence. If I have a rectangle that's 2 times as long as it is wide, how can I dimension it?
2x and x. 2x for the length and x for the width.
Perfect. Now, suppose the length is tripled and the width is doubled.
Okay.
Well, first of all, what's the area of this rectangle?
2x squared.
Okay. Now, double the length, triple the length, what does it become?
6x.
Double the width?
2x.
What's the area of that triangle, or of that rectangle?
12x squared.
The area of the second rectangle is how many times as large as the area of the first one?
Oh, 6 times larger.
Perfect.
Okay. Cool. For what value of z would the following equations have an infinite number of solutions?
Well, let's talk about this a little more in detail. How many solutions does that have?
5 plus 2, 5 plus 5, 4, 10.
Consider negative solutions.
Oh, wow. The infinite?
You got it. So when we have two variables and only one equation, we have an infinite number of solutions always.
Okay.
Okay? Wow. Now let's take this set of equations. How many solutions are there? I got
Isn't it still infinite?
two equations and two variables. So right off the get-go, you might think, well, I'm going to come up with one solution.
Yeah.
But notice the second solution is the same as, or the second equation is the same as the first equation. It's not any different.
Mm-hmm.
It's just a multiple of 2. So I haven't really added any information, which means I still have an infinite number of solutions.
Okay.
The only reason that you get a single solution is if you have two independent equations. If my second equation said x minus y equals 20, that would be completely different than the first equation, and I'd be able to solve it and come up with exactly one solution. So
Okay.
questions like this, basically, what do you see on the left side here?
Infinite solutions?
Well, you see that everything on the bottom is 3 times the top.
Yeah.
72 is 3 times 24. 45 is 3 times 15. So if 9z was 3 times 108, it would be this, what I've drawn in. In other words, we would have two equations that were basically the same, which means we would have an infinite number of solutions. So what would z have to be so that 9z was 3 times 108?
9 times 3. Would it be 108?
No. That would make the right side of the equation 9 times bigger.
Oh, 12.
No, 9 times 12 is 108.
Okay. So,
Got to be J. Got to be.
has to be J, 36?
Yeah. Notice that 9 times 36 is
Oh, it's 3 times
3 times
108.
bigger than 108. In other
Okay.
words, another example of where they don't even give you answers anywhere close to the true answer. You know, the true answer is 36, but the next lowest is 12, and the next biggest is 108. So again, you don't need a calculator on this problem. It might look like you would, but you really don't.
Okay.
You just have to make sure that 9 times z is 3 times 108. Well, 3 times 108 is 324. Once you know that 9z has to be equal to 324,
You just said that. Oh, okay.
don't really need a calculator to come up with z has to be 36.
Yeah.
Now, before we go on, let's talk about simultaneous equations. If I say x plus y equal 10, infinite number of solutions. If I say 2x plus 2y equals 20, haven't changed anything, still infinite number of solutions. What if I say x minus y equals 10?
Isn't that still an infinite number of solutions?
Well, the way to figure it out is to try to solve it.
Okay.
How would you solve those two simultaneous equations?
Um, I would maybe subtract them
or add them.
or add them.
If you add them, the y disappears. If
Yeah.
you subtract them, the x disappears. Well, let's add them. Adding is always better than subtracting.
Uh-huh.
X equals 10. Well, if x equals 10, y has to equal 0. That is one solution.
Okay.
In other words, I have two equations, two unknowns, and they're different equations. One is not just a multiple of the other. Whenever you have that, you're going to have one solution only.
Yeah. Okay.
Okay, what if I had this? Now try to solve it. Got two different equations for sure.
I guess you could subtract them,
Which gives you 0 equals 1.
and that's no solution.
That's no solution. In other words, whenever you get one number equals a different number, that's impossible. That means no solution. So
Yeah.
you have three possibilities when you have two equations and two unknowns. And that is infinite number of solutions, no solution, or one solution.
Yeah. Okay.
And you can determine which by just trying to solve it. In other words, if I go back to the 2x plus 2y equals 20, and I try to solve that, well, what I get is 0 equals 0.
Yeah. Okay.
When you get one number equals the same number, that means that no matter what x and y are, 0 equals 0, which means infinite number of solutions.
Okay.
If you get one number equals a different number, it's no solutions. One number equals the same number, it's infinite number of solutions. And the only other possibility is you're going to get a variable equals a number.
Okay.
And that's going to be one solution.
Okay. How many prime numbers are there? 37's a prime number. 41 we divide by.
What's the next one? Only
40.
only consider odd numbers, obviously.
Yeah. Yeah. 43.
About 41.
41.
Nothing divides into 41.
Okay. 41. 43. Nothing divides into 43.
Correct.
45 can be divided by like 8, 9, 9. 47.
Okay.
Divides into 47. Nothing divides into 49. Oh, no. 7 does.
7 does. 7 squared.
Yeah.
7 squared.
7 squared.
29.
51. Yeah, 51.
That's the tough one. 51 is actually evenly divisible by 17.
By 17?
Uh-huh.
Oh, wow.
3 times.
Oh, that makes sense. 21 plus 30.
10. So that's the
Okay.
that's the hard part of this problem, is that 51 is not prime, but 53 is.
Okay.
So there are 5 prime numbers between 36 and 54. And when they state it like that, then you're not considering 36 or 54, just the numbers in between them.
Uh-huh.
Not that either 36 or 54 could be prime because they're both even, but still, it's an important thing to consider. When they say between, they mean between, not inclusive of those numbers.
Yeah, okay.
Now, if you were taking the test and you had to figure out whether 51 was prime or not, what do the digits add to?
6.
6 is divisible by 3. Any number whose digits add up to a number that's divisible by 3 is divisible by 3.
Huh.
Notice 39. What do those add up to?
12. Divisible by 3 into 4.
By 3, that means 39 is divisible by 3.
Okay.
There's also a rule of nines. 81. What's those add up to?
9.
Any number that's divisible by 9, the digits will always add up to 9.
Add up.
45 adds up to 9, 54 adds up to 9, 63 adds up to 9, 108 adds up to 9, 180 adds up to 9. So if you want to determine whether a number is divisible by 9, just add up the digits.
Mm-hmm.
Always add to 9 if it's divisible by 9. And if you want to know if a number is divisible by 3, add up the digits and see if that number is divisible by 3. It can be 3, 6, 9, 12, 15, anything. It just has to be divisible by 3. So when you get to 51, if you want to know whether that's prime or not, we'll add it up. That's equal to 6. That means it's divisible by 3, therefore it's not prime.
Okay. Okay.
All right, that's a good place to stop. 47. We actually made a lot of progress to that. Make a note here. We got through 47 on the 8th. You're taking your test Saturday?
Yeah.
So this will be it for a while for doing ACT prep, I imagine, huh?
Yeah. I'll take the SAT again in April.
Okay. There's not a lot of difference. In fact, I've got 4 SAT tests, the new ones, on here, my computer. So we can always switch to SAT. But what I've found is that the new SAT is very similar to the old ACT.
Okay.
The current ACT is very similar to the current SAT. And that didn't used to be true. It used to be there was quite a few differences between the two. But now the SAT has their trig questions and their conic section questions, and additionally it has a section that's non-calculator. So
yeah,
that's probably the biggest difference at this point between the two.
Okay, cool. Well, thank you, Mr. Cohen.
You're welcome, Nick. Talk to you next time.
Yep, talk to you then. Bye-bye.